Okay, as promised, we were looking at three more questions out of the myAP. And the first one we're going to look at here is number 2. And the question here is they give you 4 statements. One of them is true regarding this summation up here. And if we take a look at the summation, we've got k going from 0 to infinity. And here's k in the power. If we rewrite this exponential as e to the x raised to the k, put that k out there as the power, we recognize that this has the form of a geometric series. So if we look at this as a geometric series, now we know what to do because we know that the summation form is going to be the first term over 1 minus r. If we can figure out the first term, in addition to already knowing the r value, here's our r value right here, then we can at least come up with the sum. So let's go ahead and do that. The first term of this occurs when k is equal to 0. And when we put 0 in for k, here's my little k, I get e to the 0, and e to the 0 is 1. So the first term of this thing is 1. And the r value we have right here is e to the x. So that tells me that the summation will be, if there is a summation, 1 divided by 1 minus e to the x. Let's go back over and take a look at the choices. Here's one that's possible. Here's one that's possible. And these are wrong. So it's either A or B. And now the choice is about x. Is x positive or is x negative? Well, we know that the sum of a geometric series will converge as long as the r value is less than 1. And that's going to be e to the x, which is always positive. I'll drop the absolute values. That needs to be less than 1. Well, e to a positive number is bigger than 1. It's e to the negatives. Remember our graph of e to the x. There's my 1 right here. E to the negative numbers, that's where I get my less than 1 values. And so there it is, x less than 0. And the answer here would be A. That's question number 2. Let's go ahead and take a look at question number 5 was the next one I wanted to look at. There it is, 5. And question 5 says, here are 3 different summations. We're supposed to figure out which ones, 1 or 1s, converge to 2. Well, kind of take them one at a time. If we look at the first one, we recognize that the terms themselves, if we took a look at the limit as n approaches infinity of the term, 2n and n, same degree. So the limit of this is 2. So what you're doing is you're adding up essentially a bunch of 2's ultimately. That doesn't even converge. So there's no convergence here on number 1. For number 2, we recognize there's my n as a power. This is going to be geometric. And in order to figure out the sum of the geometric series, I'm looking for, does it sum to 2? We need a first term. Well, here's our first term. The first term occurs when n is equal to 1. So when I plug in n equals 1 here, I'm just going to get negative 8 thirds. Or excuse me, negative 8 over negative 3. First term, 8 thirds. To find the common ratio, look for what's raised to the nth power. The negative 8 is not. The only thing raised to the nth power here is the denominator, the negative 3 to the n. So that's really, in the denominator, a negative 1/3. This whole thing would be to the n power. This is my r. And therefore my sum this time would be first term over 1 minus the common ratio. That's 8 thirds divided by 3 thirds plus, so 4 thirds. 3's cancel, and it is 2. So this is, so far, a candidate or is part of the solution. Let's check the last one. This case, the first term is when n is equal to 0. Well, that's just 1. The common ratio is the 1/2. So the common ratio is 1/2. Put these two things together and our sum is first term, 1 minus the half. That's 1 over 1/2. And it's 2 again. So it turns out for this one, the answer is 2 and 3. And I forget which choice that was. I can look at my paper here. That happened to have been choice E, even though I'm not showing you the choices. That was 2 and 3 only. Last one I wanted to look at was number 7. Here it is. And this time the question just says, what's the value of? And they do give us the 4 choices. 5 choices. It's okay. We need to figure out 2 things, first term and common ratio. What's making this problem maybe a little difficult is the fact that you have a power of n plus 1 in the numerator and a power of just n in the denominator. And there are different ways to handle it. Sometimes one way is to get both powers to be the same, in this case, just n. And here's the way we'll do that. Because we know that negative 3 to the n plus 1 is the same as negative 3 to the n times negative 3 to the 1. Rule of exponents. We would have added the powers together here. So I'm just going backwards. Whoops. Going backwards and writing it out as the product. Well, this is just negative 3. So this is negative 3 times negative 3 to the n. Let's put that back into our numerator, and we have negative 3 to the n over 5 to the n. Well, these two guys now have the same power. So this is negative 3 and a single negative 3/5 to the n. That's a rewrite, but it puts it in a much simpler, here's my r. My r is negative 3/5. All that's left is first term. N is equal to 1 is where things start. Put in my 1 here, and I get a first term of negative 3 times negative 3/5. And my first term this time turns out to be 9/5. We put these two things together with our formula. The geometric infinite sum, first term, divided by 1 minus a negative, so 1 plus 3/5. That's 9/5 divided by 5/5 plus 3, 8/5. 5's cancel, 9/8. The answer here would have been 9/8. And in the world of multiple choice, if you could go back and look, I suppose, that was D. Again, it doesn't really matter. We found the answer. That's it for now. I'll be back with something at some point in the future. There'll be other videos for you to watch. We are going to keep going, and I appreciate the work you guys are doing. This is tough times, a little distraction with a little bit of calculus. So those of you that are keeping up, those of you that are doing this stuff, I really, really thank you. All right.